Hello, everybody. Welcome. This is our capstone video for Group 9 IE441 Spring 2021. We are part of the Department of Industrial Engineering here at Iowa State University. First, we'll get into some introductions.
I'm Tucker Court.
I'm Austin Goddard.
I'm Jack Graham.
And I'm Devin Palm. So just talk about a little bit of what we did for our project. We worked mainly with two companies. First, we worked with John Deere. This is who our original project was with. But due to certain constraints and the distance from Iowa State to the facility in Springfield, Missouri, we decided to do all of our testing, surveys, and inspection at Midwest Cylinder Head in Nevada, Iowa. It's a remanufacturing facility about 10 minutes away from Iowa State University. We also worked closely with several faculty members within the industrial engineering department. So the topic of our project was we wanted to identify non-repairable cylinder heads earlier in John Deere's cleaning process. So our goal for this was to use a camera and lighting system and take pictures of several cylinder heads and use a visual inspection survey of several experts in the field as well as several non-experts. And we would visually prove what the best stage for visual inspection would be. So our main objectives for this project was first to identify the percentage of detected cracks at each cleaning stage. So there were 3 cleaning stages. We took pictures at all 3 stages and we came up with a visual inspection. And then our second objective was to create a set of standardized work instructions so future groups could follow and go off of our project if need be.
For our current state, it wasn't as standard as the other groups, but it was more involved of actually creating our process and choosing the correct equipment. Dr. Paul Kramer actually chose our camera and lighting system. We were using a Basler Ace AC A3088 camera. It's a black and white camera, but has very high resolution. And we were also using an advanced illumination, high intensity spot coaxial light for very high brightness on a very fixed spot. Aaron Jordan actually custom created our tripods. You can see in the image right there for custom angles and height. For our process of actually taking the pictures, we worked a lot with Midwest Cylinder Head to identify the correct spot for it. And we were basically taking pictures of the cylinder head at a perpendicular angle to the main firing side from 16 inches away. We were taking multiple pictures of the cylinder head just so we could get a very high resolution image so we could zoom in for our future survey, which Austin's going to go over in the future. We were taking the pictures at 3 different cleaning stages. So the first cleaning stage was right as the cylinder head comes in. It would not be cleaned at all. It would be very dirty. And then the next cleaning stage was right after an acid bath. And that would basically be like the second most identifiable stage for finding cracks. And the final stage, not every part went through this, but there is sand and steel blasting, which would clear up the surface a lot. And this would be the most identifiable cleaning stage for cracks. And for organizing photos, we were originally using Cybox just because we could use Excel for data analysis and easy collaborative work on the pictures. But we've actually just recently switched to Teams for the ideal team purposes.
So next is a side-by-side example of how we collected our data. On the left, you can see an image with our participants' markings. The blue circles are where the participants believe there to be cracks. On the right is an image of the exact same cylinder head. There are 2 arrows indicating where cracks are. As you can see, this particular survey participant was incorrect in identifying defects on the cylinder head. And that is precisely one of the things that we kept track of. In the following slide, I will explain exactly what we were keeping track of and how we kept track of it. So we were interested in finding the true positives, which is when a participant correctly circles a crack, false positives when a participant incorrectly circles a crack, true negatives when a participant identified a crack, did not identify a crack present, and a false negative when a participant circles a defect that was not there. So we kept track of our results in a spreadsheet on Excel, and we calculated the average percentages of each of the categories. We did so by summing all percentages and dividing by total instances. As you can see on the left, the higher percentage for a true positive and true negative is a better thing, and a low percentage for the false positive and false negatives is a more ideal thing. So we can see that as cleaning stages increase, there is an increase in being able to identify cracks, as well as in the very bottom table, there is a dramatic increase in ability to detect cracks among the higher level of experience.
So this semester, our project cost about $1,885. That is from the billable hours of the employees at Midwest Cylinder Head, as well as our camera and equipment setup. That was about $1,600. Our estimated cost of the first year was about $37,000. That was from the cost of our equipment that we used, and an estimate of about 8 hours a week at $85 an hour for a whole year. The potential cost savings, through some assumptions, we worked out that there's a potential for 600 of these cylinder heads to be caught in 1 year. And the cost of cleaning each cylinder head for John Deere is somewhere in the neighborhood of $250 to $1,100. So if all 600 were to be caught, that leaves the potential for somewhere in the neighborhood of $150,000 to $660,000 in cost savings in a year. And to justify our $37,000 cost in the first year, we would need to catch somewhere between 34 and 148 cylinder heads to justify our system. Those are pretty wide range of outcomes, but we had a lot of assumptions worked into our cost savings. And then we would just like to say a special thank you to everyone on this list. They all helped us in some capacity this semester, and we would not have been able to complete this project without their help.